Hey peeps, I'm here with the last video in this series on memory buffers and saving and loading your game data. Hopefully by the time I've finished editing and uploading this, the expanse will have been saved, hashtag save the expanse. So far we should be able to loop through your save game data, amend it and overwrite data whenever you need to, add information to the header of your file. But what if you want an object that doesn't write the data or hold the entire data set in memory constantly, but just accesses the entry it requires and then throws the rest away? This will mimic the kind of tool to game relationship that you get in game development. So you'll usually have a tool that creates all the data that your game uses. It sort of defines it all. This tool will usually have a lot of extra stuff, and when you export it, it will strip everything out to just the data that the game needs. Object file that we've been creating all the previous videos, it represents this tool. It's creating, modifying and outputting the data for you. What we're going to create now is object accessor, which is going to represent the game, and that just loads the specific entry it needs and nothing else. So what we're going to do first is add in a new workspace and create a new object. Dropping it into that workspace, we're going to call it object accessor. There we go. And we need a script to go with it, which we're going to call access entry. And that script will return the data we're asking for. So if you close that and return to the object itself, first thing we need to add is a create event. Now this is going to need a few bits and bobs that we also had with object file. So we need a way of displaying the data that we've read in. So we're going to use the same display name, display age, etc. variables that we used on object file. That way we can still use the setup display function, and they'll be compatible. So we'll say display name equals display age equals, and just open close quotes here is just going to initialize the variable as a string. That way when you go to use it somewhere, because if you just initialize it as nothing, and then you go to use it as a string, it'll throw an error. So we need to initialize it as a string, but we don't need any information in there. We just double quotes to initialize it as an empty string. Display month equals burpity burp. Display time equals double quote. So these will be the variables we use in the draw function to display text that just says this is what's in the data. Now we need a way of recording what entry we're currently using. So selected entry equals 0. So now we can log the index we require each time. And we're going to need the same file num variable that we use to save our data to begin with. So we're going to go file num equals open quotes, close quotes. That's not how you spell file. Let's try that again. There we go. And if we go back and look at the previous object and check what the file number you used to save your data was. Now for me, it's saying here file number 3, but whatever number you have there, put it in here. That's all you need to do to set this object up for its create event anyway. We need to add a step event now to handle accessing the actual data. Now what I'm going to do is set it up so that you press a key, a number key along the top of your keyboard, and it will load the corresponding entry that matches that key. So what we need to do is loop through, because the keys are numbered. Anytime there's a number, you can use a for loop and use the index. So we're just going to create a for loop. And we'll use it, k is less than 10, that gives us 0 to 9, which is each of the keys, incrementing by 1 each time. So now we have a loop that will give us an index for each key. Then we need to check if the key's been pressed by saying if keyboard check pressed. Now we need to supply this function with the key code. But to get the key code, we're going to use this function called ORD. So we're checking against the Unicode character returned by ORD. So we need to tell it what Unicode character we want to get the Unicode for, and that's going to be this index, because we want the Unicode for whatever number we've pressed, which is the same as whatever index we're currently looping at. But of course, this index is a number, and we need to give ORD a string. So we need to use the string function, and we're going to pass the string function the k. Then we open and close squiggly brackets. And I did not put enough close brackets there. There we go. So we're going to say db entry equals access entry. So we're going to use this function that we're about to create, this script that we're about to create, access entry. We're going to set this up so that we supply an index, which will be whatever the current iteration of the loop is, the same index, because that corresponds to the key we've pressed. We're going to pass that to access entry and have access entry return a data structure map, which will be placed inside the db entry variable. Unless, of course, the entry doesn't exist or the file doesn't exist, in which case I'm going to have db entry return no one. That way I can say if db entry is not equal to no one. So now in here I can put a check to say, has it actually returned something? Yes, it has. And then I can do some stuff based on the existing data map, which will simply be to say set up display, passing it db entry. So that's using the same function we created in the previous video, and I'm just passing it the data map that we've loaded in. And I'm also going to log the currently selected entry, like that. Now, there's a few things we could have done here. We could have, instead of saying db entry is not equal to no one, we could have said, like, use the data structure exists, and said if data structure exists, this ds map exists, then do this. But that would have created a slight little bit of overhead, because you'd have to have accessed that function, and it's a lot quicker and easier to have set this function up to return no one if it hasn't got anything, and then check against that for being returned. So having done that, we now need to set up the draw event to actually display the data we've requested. Nice easy way to do this. Go back to your other workspace where object file is, and the draw event here, and just grab everything from entry. So we don't need the database name because we're not actually going to load that in, but we just need the other lines. Copy them, paste them in here, and then you can make one change because we're not using entry position, we're using selected entry. So change that to display that, and that's all you need to do to now be displaying the data. So what about this access entry script? So this is going to be the nuts and bolts. This is going to actually get the entry that you've requested. So the first thing you need to do, put a little comment to say what the script does. Read requested entry from buffer and return. So we put that there. First thing we want to do is actually create a variable to hold the index we've been sent. So var entry num equals argument 0. So what we have here is the index within the file that we've been asked to get. That's the entry num. We then need to do the same var file variable that we've used in the previous videos, which will be the same file plus file num plus dot buff. So having done that, it should load the exact same file we've already saved earlier that we created in the previous videos. It will now access that. But of course we still need to check that it exists by saying if file exists file. Otherwise, if it's been randomly deleted or removed on its own, and you don't check that it exists and try to access it, you're going to get a crash. And if it doesn't exist, we want to say else return no one. So as we saw earlier, having used this script and returned a data map or returned a value, we need to check that that value isn't no one. So here it's saying, okay, if the file doesn't exist, return no one. It sends no one to here. This is check. If it doesn't equal no one, do this stuff. And because this has returned no one, because the file doesn't exist, it's just going to skip this if loop and not do anything. Which is what we needed to do or not do. So if the file exists, we want to actually load it and read from it. So we'll go var get buffer equals buffer load file. So we're going to load the file. As we know it exists, we're going to load it into the buffer. So now we're going to read the header. Now we don't need to read the entire header, we only need to read the relevant information. So in the previous video we went about creating this header, and if we go and look at the, or more specifically if I just drag in the right header script, pop it there, we see the order in which we write stuff. At the end we wrote date starter point to byte 0, and at the beginning we moved to byte 2 and wrote record size. So the data stream will be the first 2 bytes are the start point, the second 2 bytes are the record size. We don't need to know the entry index, we're not amending the file, we don't know the name of the file, we don't need to check the version number of the file because that's only for like, well, you may want to do that to check that your stuff's out of date. In this instance we're not going to, because generally you should, when you're developing a game, you should know what version all your files are, and you should plan according to make sure it's only loading the correct version of the file. But you might in a debug version want to actually have a like debug it thing, which, well, you can't actually do that in Gamemaker anyway, they haven't added that feature yet, but in a debug version you could check against it. But for what we're doing right now, we don't need any of these. We only need to know the data start point, which is at byte 0, and the record size is at byte 2. So we're just going to read the first 2 bits. And we're just going to make local variables to store them. So var data start, it's not ASL start point equals buffer read get buffer to check what that was now. I believe it was a U16. Should have left that open. Yep, they're both U16s. U16. So that's reading the data start point. Now if you copy that, go copy paste again and change the variable name to record size underscore record size. Then we read the next, so yeah, this reads the first 2 bits, which corresponds to data start point. This reads the second 2 bits corresponding to the record size, which is the only information we need to know right now. Or rather, that's all we need to actually acquire from the header. Now we have the 2 pieces of data we need to directly access, which, or rather the 3 pieces of data we need, which is the entry number, the data start point, the record size. Those 3 pieces of information give us the position within the buffer to read the entry from. But before we need to do that, we need to make sure we're actually reading from a valid point inside the buffer. So essentially, if you've only created 5 entries and you press key 7, it's going to ask for entry 7, and entry 7 doesn't exist, it's past the end of the buffer. So we need to actually check that we're still inside the buffer. And we're going to do that by getting the size with var size equals buffer get size. get buffer. That's not how you spell size, that's how you spell size. So now we know the size of the buffer. We're going to create another variable which actually calculates the specific position we're aiming for, which is the var get position equals data start point open plus open brackets entry num times record size. So now we know the position we're looking for. So what we need to do is check that that position is inside the buffer size by saying if get position is less than size. If get position is less than size. Because if it is, we're inside the buffer and there will be something to read. Else we're outside the buffer, and as with if the file doesn't exist, if we're outside the buffer, we're going to return no one because there's nothing to read. So inside here, we know the position we want to read from, and we know that position is inside the buffer, so we know there's a record to be read, so let's read it into our variables. Or more specifically, let's read it into a data map that can then be returned by this access entry script. So first thing I want to do is actually position, using buffer seek, position the read position to the get position that we want to use. So we go buffer seek get buffer, comma, buffer seek start get position. So we place the read head at the byte entry for the beginning of the record we're after. Now we create a data map to store it in. Var data equals ds map create, and then we start reading the data in. So to save time and so that I'm not sitting here typing loads out, if we go to load file, drag that in and scroll down, you can just copy those lines there. Might need to actually copy those lines there, paste them in, and we're going to need the var timeline as well. So basically we're copying all the buffer read lines and the ds map add lines from the load. This ensures we have the same load signature. We also need to copy get buffer and paste over where it says read buffer. So having done that, we've read in the same order that it was written by the obj file. We have read in the time, the name, the age and the month. So now we have all our data, and we just need to return it by saying return data. Or return data? Let's return data. And boom, we have now loaded or attempt to load a file entry, and this will either, so now the script either returns because it's found a correct entry and returns it, or it didn't find a correct entry or a file and it returns nothing. So this is now receiving a data or no one, and if it's not no one, it's data. So if it's data, we pass it to setup display, which sets up these variables so that it'll get written on the screen. If you're wondering why that error's there, it's because it still for some reason thinks there shouldn't be any arguments when there should be. So if I delete that and then put it back in, it updates and now there's no error. So now, fingers crossed, if I save this and run it, or rather if I add it to the room first, best not forget that. So if you open your room up, and then drag and drop object accessor, if I just zoom that out a bit, make sure it's in, there we go, that'll do. put it in the room, close the room, then save and run. And here it is. If you use the cursor keys, you should be able to see on the left we have obj file, and if you use left and right on your cursor keys, you should still be able to see all the data you've previously created. Now if you pick one, let's say entry 3, Kate Jones 54, if I press key 3, obj accessor is displaying that entry. If I go to 5, Kate Ramsey, there we are, press key 5 and we have Kate Ramsey. If I press enter to replace Kate Ramsey, you'll notice obj accessor hasn't updated yet because it hasn't loaded anything in, but if I press 5 again, it becomes Tracy Burke to match that. And we see that entry 6 is the maximum entry, so if I press key 7, it displays nothing because there's nothing to display. But it doesn't crash because it hasn't found a bad entry. So yeah, that's it. That should be all you need to know about memory buffers and how to use them to load and save data. Now for a little bit of a bonus extra, I'm going to show you what the C# code looks like, as it's basically structured the same way, but it's just like keywords are different and stuff. So you see here, I've created a bunch of variables. Now in GML, when you create a variable, you just declare the variable and go equals and give it the whatever number you're assigning it. So in this, but in C# you have to actually specify what you want the variable to be, and instead of having just a single number or string and stuff, you get a bunch of different types, and these correspond with the different types of buffer that you read and write to, the different sort of buffer type that you read and write to in GML when you're using the buffers. So what I've done here is I've just created some variables that correspond with the types that GML uses. So we see here I've called this variable buffer U8 because it's going to correspond with the buffer U8 in GML, which is an unsigned 8-bit integer. Now C# calls an unsigned 8-bit integer a byte, and then the signed 8-bit integer it calls an S byte. For 16-bit it's called short and ushort. Then you have a uint for the other signed 32-bit integer and an int for the signed 32-bit integer, and then ulong for the buffer U64. Then we have float and double for the floating point buffers. So what we see here is the data has been created. Now the next line here we see is setting up the file, which is say file stream out file equals new file stream test file.buf. So what I've done there is create the actual file and open it as a new file. Then binary writer out binary equals new binary writer. This creates a binary stream to write to. So this is essentially the same thing we saw with our GML code. So we see in GML we have the similar thing of we're setting up the file and we're creating the buffer. Then we write to the buffer. And if we look back at the C#, we see the same here. We're writing to this buffer, which is also writing to the file. It works slightly differently in that you write to the file and the buffer at the same kind of time. But in the same way that you write the data a byte at a time, in the same order you did in the GML, where we write each thing a byte at a time, then you close the writer and save the file. See here I also did the test of making sure it loaded up correctly. Now the reason I'm showing you this is because with C# you can save this file. So this test file I've got here that I created, test.buf, it's saving this binary information, these bytes, to a file called test.buf. Well, that file can now be loaded inside GML. If I go down here, see I've created, where is it? I've created this from C# object, and inside this what I've done is I've created this initialized this set of variables here. I then set up the file testfile.buf and load it, and then if I load into these variables the values that correspond with the values that were saved out in C#, which are here, then it will load them into GML in the same way they were saved out in C#. Now the only thing you have to be careful of, or have to make sure you do, if we look over here to the right, down here, we have included files, and your exported from the different software has to be added as an included file. Then you can access it here. So if I just run this quick, so what we see here is the same numbers, but this time they're loaded inside GML. So here we see the numbers created in C#, and here we see the corresponding numbers displayed inside GML. So why is that useful? Why is it interesting that we can create files in C# and save them out in GML? Well, C# has a bit more kind of functionality when it comes to creating tools. So if you want to create an editor and some cool tools to make your sort of levels that are different to what the levels you can make inside a room editor, then you can do all this in C#, and you can save the files out in C#, and then you can import them into your game and load them in GML. And likewise, if you can figure out the file format to like something like Blender, you can just load the file into GML. Once you know how to load all the bytes from a stream, all you have to do is find out what the signature is and where those bytes are, and then you can load them and put them where you need them. So yeah, there's the end of the little bonus bit, and yeah, if you subscribe and hit your notifications, you'll get my next set of videos, which will be hopefully coming reasonably soon. Otherwise, I'll put some little boxes up here in the top right and stuff, and you can click on things and see other stuff, and yeah, have fun making games. I'll see you next time.